Say we have two sequences, X and Y, and let's say that we have found a solution. We have found the solution to the LCS, and G is our LCS. That is, G is the longest common subsequence between X and Y. Now, let us see if the optimal substructure property holds true or not for this problem. Say we come up with a situation where Xm equals Yn. For example, if X is a sequence like this and Y is a sequence like this, then the scenario that we are imagining is when we have Xm equals Yn. That is, the last character in X matches the last character in Y. Then, obviously, Gk should also be equals to Xm and Yn. So one of the characters, the last characters of our LCS should also match Xm and Yn. Why so? Because if they don't, then this wouldn't be an LCS, right? We also argue that if this is the case, then Zk minus 1, that is this subsequence of our longest subsequence, is LCS of Xm minus 1 and Yn minus 1. That is, we argue that this BCB must be the LCS of Xm minus 1 and Yn minus 1. Now, how and why can we argue that? We argue this is the case because say that BCB was not the longest common subsequence between Xm minus 1 and Yn minus 1. Now, if this was not the longest common subsequence, then there must be another longest common subsequence between Xm minus 1 and Yn minus 1. But if there was such a longest common subsequence, then we could easily add the last characters, which are already that we know are equal, as plus 1 to the longest common subsequence, and that would contradict the original assumption that G is the LCS of X and Y, right? So from this, by contradiction, we can prove that we can show that if Gk is the subsequence, if Gk is the subsequence of Xm and Yn, then we can also say that Gk minus 1 is the longest common subsequence of Xm minus 1 and Yn minus 1. So there you go. This clearly shows that solving Gk minus 1 can be used to solve Gk. So this shows the optimal substructure property of the LCS problem in this particular case of when Xm equals Yn. Now let's look at two other possible scenarios. It is also possible that Xm is not equal to Yn and Gk is not equal to Xm. Here's an example. So here is X and Xm is A. It is not equal to Yn, and Gk, which is B, is not equal to Xm. Now, this implies that G is an LCS of Xm minus 1 and Y. And this is so because here's our Xm minus 1, Xm minus 1, and here's our Y, entire Y. And we can say that G is a subsequence of Xm minus 1 and Y because the last character in X is not a part of Z. And if once again we can prove this by contradiction, that if this was not the longest common subsequence, then we would have another longest common subsequence between Xm minus 1 and Y, which would also be at least the longest common subsequence between X and Y. So similarly, there could be another scenario where we again have Xm is not equals to Yn, but then this time Gk is not equal to Yn. That is, Xm is not equals to Yn, but then Gk is not equal to Ym. So then here once again we can clearly infer that in this case G is a longest common subsequence of X and Ym minus 1. Yn minus 1. So with the optimal substructure property applicable to the LCS problem, we can actually go ahead and apply dynamic programming.